So my topic is artificial colouring, and my name is Putri Marsya Kristina binti Nur Azrin with the matrix number of 2021881316 and under the supervision of Madam Intan Nur Eliza Fadlina binti Kamarudin. Several types of dyes are available in the market as colouring agents to food commodities. Some commonly used synthetic food dyes include brilliant blue, indigo carmine, citrus red, fast green, erythrosine, allura red, and sunset yellow. These main food biocolorants are carotenoids, flavonoids, anthocyanidins, chlorophyll, betaline, and crocin. So the question is, how safe are these food colorants? This has led to a lot of studies both by individual researchers, corporate organization-sponsored, and even government-sponsored researchers. This is to authenticate the benefits or risks associated with the use of food colorants. This review critically evaluated scientific researchers from various published journal articles and reports with a view of clarifying the health implication of using these food dyes. However, natural food colorants have been found to be relatively safe to humans. Besides the coloring property, they have been found to possess a number of pharmacological properties like strong antioxidant, anti-mutagenic, anti-inflammatory, anti-neoplastic, and anti-arthritic. Do you know artificial colors are food additives used to provide or enhance characteristic colors in food products? They are obtained from synthetic processes and are typically made up of hydrocarbons, that is complex, nitrogens, and sulfur ions. It is also originally manufactured from coal tar, which comes from coal. Today, most synthetic dyes are derived from petroleum and crude oil. So these are a few molecular structures that I found for tartrazine, allura red, and brilliant blue. It is mainly composed by sulfur ions, complex hydrocarbons, and as I explained just now. So, would you drink black water? Or how about clear Pepsi? So now, what about using pink butter? Believe it or not, these products actually existed, but not that long ago either. But there is a reason these food fads did not last. Consumers prefer that the color of food matches its flavor. The link between color and taste is logical. Since oranges are orange, we expect orange-colored drink to be orange flavored. Red drinks should taste like cherries, while purple drinks should taste like grape. If a food is multicolored, it could be moldy and should not be eaten, unless you are eating blue cheese, which gets its distinct flavor from mold. Do you recognize all these foods? So we have candy, M&M, lollipops, cereal, treats, and nuts. Yes, you should worry now. Why? An astonishing amount of food we eat is processed. These foods are altered from their natural state to make them safe, say to remove harmful bacteria or to make them appealing, and to prolong their shelf life. About 70% of the diet of the average US resident is from processed foods. Much of what we eat would not look appealing if it was not colored. Think of food coloring as cosmetic to your food. Without coloring, hot dogs will be grey. Yuck! There has been a rising concerns over health implication. Although artificial colouring is commonly added to food, it doesn't necessarily mean that it is safe to eat. First, it disrupts immune system. Consumption of food containing artificial dyes can cause an inflammatory response in the body, which leads to the activation of immune system. It also increases the amount of white blood cells entering the bloodstream. Artificial dyes contain small molecules which are able to attach to proteins in our body. This can cause disruptions in the immune system since the immune system finds it difficult to defend the body against them. Secondly, it contains toxic contaminants. Do you know red tree was found to be an animal carcinogen way back in 1990? But still, for some reason, it is still allowed in our food. Third, red 40 has been shown to trigger hypersensitivity in children. Yellow 5 has linked to hyperactivity, hypersensitivity, and other unfavorable effects in children. Last but not least, it triggers a smart attack. How do we overcome the problems caused by artificial coloring? So first, people should try to stick to unprocessed naturally colored foods for their health. Second, relevant government agencies should issue an immediate advisory to parents warning them to limit or avoid their children's intake of additives if they notice an effect of behavior. Third, law implementation. Some laws making it difficult to ban certain food colorants should be amended to make it no more difficult to ban food colorants than other food additives. Fourth, food industry. The food industry should voluntarily remove harmful food dyes and replace them with natural alternatives if possible.
Years ago, I featured this landmark study, randomized, double-blind, placebo-controlled food challenge, published in perhaps the most prestigious medical journal in the world, showing artificial colors increased inattentiveness, impulsivity, and hyperactivity among young children. So, what happened? Well, the British government said, okay, there's no health benefits to these dyes, only health risks, so it's a no-brainer. The British government mandated that food manufacturers remove most of the artificial food colors from their products. In fact, the whole European Union said, fine, you want to continue to use these dyes? Then you have to put a warning label stating, look, may have an adverse effect on activity and attention in children. So many international food companies have taken them out of their products in Europe, but they continue to use them in the same products here in the US, where similar regulations are not currently in place. Why not? The FDA put together a committee that looked at that same landmark study and conceded that the food additives may have resulted in changes in behavior, but the type of treatment effects reported in the study, even though the investigators referred to increases in levels of hyperactivity, were not the disruptive excessive hyperactivity behaviors of ADHD, but more likely the type of overactivity exhibited occasionally by the general population of preschool and school-aged children. To which a distinguished toxicologist responded, look, low-level lead exposure may only shave off a few IQ points off of kids, but just because they'd still fall within the normal range doesn't mean it's okay to expose kids to it. In fact, now looking back, the lead and leaded gas may have been causing brain cancer and even urban violence. The aggravated assault rate in cities around the U.S. seem to follow the lead levels in the air pretty closely. Anyways, CSPI continues to call on the FDA to ban food dyes and for food companies to voluntarily stop using them. Good luck with that. In the meanwhile, some researchers recently suggested a way to see which food colors may be damaging your children's brain. Advising parents to test artificial colors by purchasing little bottles of food dye at the grocery store. Then have your child do some homework or something, and then have them chug down an artificial color and see if it affects their handwriting, reading, math at 30 minutes, then at 90 minutes, then at 3 hours. Also, see if they get irritable later, have problems sleeping. Then, if that's okay, you try even more to see if that will mess up their mind. If I may offer an alternate suggestion, maybe we shouldn't be buying our kids processed crap in the first place.
So there are mainly three methodologies for food dyes determinant. First, we have spectrophotometry. Second, we have high-performance liquid chromatography. And thirdly, we have mass spectrometry.
This technology is based on a flashing xenon lamp, which produces intensive light with wavelengths ranging from ultraviolet to visible wavelengths up to 190 to 1100 Newton meter. So, the beam passes the cuvette containing the sample. This leads to absorption at specific wavelengths. So, the light beam guided by the glass fiber passes via a slit into a spectrograph. And this is where the beam hitting the grating is reflected and dispersed into its wavelength components onto the CCD detector pixels, enabling simultaneous measurements from ultraviolet to visible. So, this is where we can see the individual intensities recorded by the CCD are computed and it is displayed at the terminal. So this is the overview of how a UV-VIS spectrophotometer works.
So, as a result of carcinogenicity, hypersensitivity reactions, and behavioral effects, and other toxicological considerations, food dyes cannot be considered safe. I strongly advocate that food and drug regulatory agencies of various countries should rise up and ban food dyes, which serve no purpose other than a cosmetic effect. Borrowing a leaf from Japan and all European countries have banned trading of synthetic color-made products. In the meantime, food companies should voluntarily replace dyes with safer, natural colorings, which has been found to be relatively safe with health benefits.